In this video, I'll be discussing Spoilboards and other methods of usage of the vacuum table. So, when it comes time to need a new Spoilboard, you're first of all going to want to get a sheet of about 3/4 inch 97 by 49 MDF or LDF. We have our current one right here. And I've got this area where I made an extension to the Spoilboard. And so this is a good example. Your first step is you're going to want to clean in these ridges as much as possible. So I've got some sawdust here that I would want to try my best to clean out. You're going to want to place some kind of rubber gasket inside the general perimeter of the board that you're going to be laying down. And that's just laid in there. I believe that we're currently just using some weather stripping. You'll notice all of these white screws. You're going to want to take all of those white screws out within your gasket perimeter. That's what's going to allow the vacuum suction to actually come through. So these come out nice and easy. And when the vacuum is activated, the suction will happen through here. Now what you can do is simply lay your Spoilboard on this, and then whenever you activate the vacuum and are actually sucking down through the table, the Spoilboard will be sucked down. However, what I like to do is I like to bolt it in place. And this is good for having a more consistent abrasion down to the table and having it consistently stay in the exact same place. It's pretty heavy, so it doesn't slide around that much, but I like to screw it down like this to minimize any sliding around or any changes in the positioning, or it can also reduce some of the effects of if your board is bowed a little bit. And so, we've got a handy program on here. If I open, I go to desktop. I want to navigate to shop parts, Spoilboard, and here we have Spoilboard screw points. So this is nice. You'll put in the thickness of your Spoilboard. Mine right now is just above 3/4 inches. And what this will do is it'll drill an 8mm hole and some countersinks. And what I actually like to do is I use this, and then I use my own program, which I have in downloads. That I call New Spoilboard Screw Points Countersink. And in this program I just added a little bit more of a countersink, sort of an outer ring to hold the screw. And you can kind of edit that based off of the original file if you feel that you need to change it. So what you'll want to do I need to load something. You'll want to place your board right up against these pins and as far against these pins as possible. And that will screw it in the correct place so that the holes line up correctly. I've got this one screwed into, I believe, the furthest left and furthest down screw hole. You're going to be using these 8mm diameter bolts. And that makes it a lot more effectively held down to the board. And from there, you're done. You've got your new spoil board. Make sure you update your green tape indication of the spoil board's thickness, and you're good to go. One thing that I have not tried yet, but was suggested to me, is that you can get a better seal of suction if you seal the edges of this board somehow with like a silicone material or anything else that would reduce the air that is leaking out. With your spoil board, when you have cuts along the edges and just cuts that are too deep in the thing, as you may have accidentally cut too deep throughout processing, that's going to reduce your vacuum suction. So you'll find that the more you use a spoil board, the less effectively parts and just pieces of plywood will stick down to it. Now, I mentioned in a previous video that one way to get around not covering enough surface area is just to cover the board in other things that aren't even being cut. You may get this indication with the error, vacuum fixture error. Now, sometimes a piece is just too small that its own weight won't really hold it down well enough. So that's where your pods come in. And we've got these pods here. And they fit nicely into the grooves on this table. These are some bigger ones, but we've got some smaller ones as well. Now, if you've got a piece that's too small to stick down, what you can do is you can arrange pods on this table for it to sit on. And air will travel through the little pathways in these to suck down your piece. The first step for that is you want to place your pods where you want them. If I can get it in the groove here, there we go. And let's say I want to hold down the piece with just this one. Next, you want to flip them up, and you have to take out all of the white screws that are underneath the pods. And you want to make sure that the entire screw hole is being covered so you don't want to have it just half covered like this, because then you're going to lose suction. So you want to cover it up, and you want your piece that it's supporting to be completely covering the holes in the top of the actual pod. Then you'll lay your piece on there, you'll put it up against these for your 0 point, and you can cut. Now, there's a programming side to doing this as well. So let's go back to Maestro CNC. We'll start a new project. We'll just make it a 10 by 10 piece. We'll just add some quick perimeter routing. Just use the first tool I can. Make it go the full depth by typing DZ1. There we have it. So, next, you want to go to this Machines tab, and then you want to click Setup. First step, you don't want your work area to be EH anymore. We want it to be HG, which will be just this section of the table. So go up here to Machine Parameters and change this to HG. And now you see that we're only using this half of the table. Next, if you look over here, this automatically comes up when you're in setup. Supports. Now, I've never had to use the big pod that I was giving you an example of. I only ever really use the small pods, and that's these right here. So all you got to do is take this and click and drag it, and just place it somewhere underneath the perimeter of your piece. And there you go. Now the machine knows that it's going to be cutting on top of these suction pods. So then we'll go up, we'll save this. I'll call it Pod Test. Go back to my Maestro Active. It's very easy to accidentally click more than one thing that you're looking for, so watch out for that. You'll find yourself accidentally going into one of the folders within the folder you're looking for. So we'll find our pod test here. And now when you're using the pods, your Z offset is 0. You have no Z offset here. The pods are a certain height, and because we put them into the programming, it knows how high it's supposed to be. You don't want to Z offset it unless the context of the thing that you're cutting means that you want to leave some thickness at the bottom of it. And your X and Y offsets, now instead of being from here, they're the opposite. So an offset of 1 inch in the X direction will send you 1 inch this way, and the Y stays positive. So you'll be sent 1 inch this way if you put in 1 inch for the Y. You see our work area is HG now. That's what we want. Still vacuum device locking. We'll load that. We need to turn on our vacuum pump. And then now, you'll want to activate your suction over here. And see, well, the light came on now, but all the suction is coming through the top hole of this pod. And then once you're done, You want to move your pods back to their proper place, and you have to make sure to put all of your screws back. Because any place that air is escaping is going to reduce your overall suction. It's going to reduce your overall suction power. So I make sure all of these are back on tight. The only screws that will stay out are the ones that are underneath your spoil board. Across the entire grid underneath this thing, there's no white screws in the holes. But as soon as it's exposed, you need to screw it in.